Here we have a SAT math problem. Okay, let's go to the question. On simplification, the given expression is equal to what? So here we have four answer choices. In each answer choice, we have the stuff that can be equal to this given expression. That's what we have to find. Okay, now what I'm going to do is I'm going to take the first term of the expression. That is 1 over 1 positive a to the power of m negative n positive a to the power of m negative p. Now let me do some simplification over here. Let me write the numerator 1 positive. This a to the power of m negative n can be written as a to the power of m divided by a to the power of n. Using the coefficient rule of exponent, the same thing we can do for this one. That is a to the mth power divided by a to the pth power. Okay, now 1 over 1 positive. Now we are adding two fractions with different denominators. Okay, now what we can do is we can do cross multiplication to add these two fractions. Cross multiplication means we have to multiply this numerator by this denominator and also this numerator by this denominator. Finally, we have to multiply the two denominators. Okay, now let me multiply the numerator a to the mth power by the denominator a to the pth power. When I do so, I am getting a to the power of m positive p, because here we multiply two terms with the same base a. Whenever we multiply two terms with the same base, we have to write the base once and we have to add the exponents using the product rule of exponents. Okay, now let's do the same thing. When I multiply this one a to the mth power by a to the nth power, I'm getting a to the power of m positive n. Finally, I have to multiply the two denominators. Here we multiply two terms with the same base a, so I have to take the base ones and we have to add the exponents n and p. That is then we get n positive p. Okay, now what we can do is we can add this fraction and the integer 1. Whenever I want to do addition or subtraction between an integer and a fraction, I have to multiply the integer by the denominator of the fraction. Once I'm done with the multiplication, I can take this one as a common denominator. Okay, let me do it over here. That is 1 over, now let me multiply this 1 by this denominator. Then I'm getting a to the power of n positive p. Now we can take this positive sign and we have to write this numerator as it is. It is a to the power of m positive p positive a to the power of m positive n. Let me do it. Everything is divided by a to the power of n positive p. Now this one is taken as a common denominator because we have multiplied this integer by this denominator. Okay, now what I'm going to do is I'm going to keep this numerator 1 as it is and I change this division as multiplication. When I change this division as multiplication, I have to take reciprocal for this fraction. Then I'm getting a to the power of n positive p all divided by a to the power of n positive p positive a to the power of m positive p positive a to the power of m positive n. Now we can multiply this 1 and this term a to the power of n positive p. Then I'm getting a to the power of n positive p. Let me write it in numerator. And in denominator, we can rearrange the terms over here by writing the letters of the exponent in alphabetical order. In that case, I'll be having this one as the first term, that is a to the power of m positive n. Then I'll have a to the power of n positive p. At last, we'll have a to the power of m positive p. Okay, now I just simplified the first term of the given expression and I got this one as a result. Okay, now compare the first term over here and the result of the simplification over here. So when I look at the first term we have over here, in denominator we have 1 positive, a to the power of m negative n, a to the power of m negative p. Particularly notice here at the exponent, n is subtracted from m over here and here p is subtracted again from the same m. So here n and p are subtracted from m. We have these n and p added at the exponent in numerator over here. And in denominator, we have the three letters in order, m, n, then np, then p over here. Okay, what if I simplify the second term in the same way? Then what will be the numerator? Since n and p are subtracted from m, the same n and p are added at the exponent in numerator over here. So when I do such simplification over here in the second term, so here m and p are subtracted from n in this term and this term. Then this m and p will be added and we'll have m positive p as the exponent of a in numerator when I simplify the second term, and also the same logic we can do for the third term as well. Okay, now I'm just going to erase this stuff and I just consider only the result on simplification of the first term. Okay, let me erase it. Okay, let's continue. Here I have written the result after the simplification of the first term. Okay, now let's do the same thing for the second term and third term as well. Okay, now let me take the second term, that is 1 over 1 positive a to the power of n negative m positive a to the power of n negative p. Okay, here as we have discussed already, n and p are subtracted from m. So the same n and p are added, and n positive p is taken as exponent for a in numerator. So here m and p are subtracted from n. So we have to add this m and p, and m positive p should be taken as exponent for a in numerator. That is a to the power of m positive p, and in denominator we have the same stuff. That is a to the power of m positive n, positive a to the power of n positive p, positive a to the power of m positive p. Okay, now let me take the third term and do the same simplification. That is 1 over 1 positive a to the power of p negative m, positive a to the power of p negative n. So here m and n, both of them are subtracted from p. So this m and n should be added. M positive n should be taken as exponent for a in numerator. Then we get a to the power of m positive n divided by, and the same denominator will have, that is a to the power of m positive n, positive a to the power of n positive p, positive a to the power of m positive p. Okay, now I got the result after simplification of each term in the given expression. So now what I have to do is, in this expression I have to plug in this one for the first term, and this one for the second term, and this one for the third term, and add these three results. So the at last the stuff what I'm getting is equal to the expression. Okay, now I'm just going to plug in these results for the terms in the given expression. Okay, now let me erase the stuff and continue. Okay, now let me plug in the results after simplification for each of the three terms in the given expression. Okay, and for the first term we have a to the power of n positive p, because here n and p are subtracted from m. So the n and p are added. N positive p is taken as exponent for a in numerator. In denominator we have a to the power of m positive n, positive a to the power of n positive p, positive a to the power of m positive p. Okay, in the second term, m and p are subtracted from n. That m and p should be added. M positive p should be taken as exponent for a in numerator. Then we get a to the power of m positive p. In denominator, the same stuff what we have over here. That is a to the power of m positive n, positive a to the power of n positive p, positive a to the power of m positive p. And here in the third term, so here m and n are subtracted from p. So we have to add m and n. M positive n should be taken as exponent for a in numerator. Then we get a to the power of m positive n divided by a to the power of m positive n, positive a to the power of n positive p, positive a to the power of m positive p. So whatever denominator we have for the first term and second term, the same we have over here. Here we are adding three fractions with the same denominator. So now what we can do is that we can take this one as a common denominator, and we have to add the three numerators. Then I'm getting a to the power of n positive p, positive. The second numerator is a to the power of m positive p, and the third one is a to the power of m positive n. And we have the common denominator for all the three fractions, that is a to the power of m positive n, positive a to the power of n positive p, positive a to the power of m positive p. Okay, now look at the expression in numerator and denominator. Whatever three terms are added in denominator, the same three terms are added in numerator. The order is different. Order doesn't matter. So here in this expression, the stuff we have in numerator and the stuff we have in denominator are equal. So we can cancel them, and it is equal to 1. So on simplification, the given expression is equal to 1. We find 1 in answer choice C. The correct answer choice for this question is C.